Right, welcome to the enjoyment of mathematics now from Siafunda. We want us to continue and look at how we do these types of simultaneous equations. This is about 6 to 8 marks in your examination, the simultaneous equations. So let's make sure that under algebra, we understand and so marks. This one, the first thing that we need to do is to name our equations. Equation 1 and equation 2. Once you've got these two equations, so whenever you see this, you must know that I'm referring to equation 1. When you see that, I'm referring to equation 2. Now the next thing to do is to find the third equation. The problem here, I've got two unknowns. I must at least have one unknown. I've got to kill one unknown so that I'll have only one. So when I look at the first one, it is easier to work with than the second one. Go to the first equation, to the simpler of the two equations, and make one the subject of the formula. I've got x, I've got y. Which one can I easily make the subject here? Is it x or y? It is x. I can have x equal to something or y equal to something. It will be difficult to find y is equal to something. You can do it in that way, it's fine, but I would suggest that you take the easier one. Mathematics is easy, especially if simplified. Let's take the simpler route here. The simpler route is to have our x as equals to 3y. Take this 3y this side, it will be positive 3y. Then we'll be left with that one also, 3y plus 1. This is equation 3. Remember, how did we get this equation 3? And where did we get this equation 3? We got it from equation 1. So in other words, we've already used equation 1, but we have not done anything to equation 2. So the next thing to do is to take this equation 3 and substitute to the equation that we have not touched at the moment. In this case, it is equation 2. What is this saying to me? Whenever I see x, I've got to push this, 3y plus 1, because this is the same as that. Now, let's write equation 2. The next step, we're going to substitute equation 3, which is this equation, into equation 2. Equation 2 is this one. Rather than writing the whole thing there, we refer to them as equations as we have labeled them. So we're going to take equation 3 and substitute it in there. So what is this saying to us? Whenever we see x, we're going to push this value, which is 3y plus 1. So there'll be no x there. So we're going to push this in two places, in this one and there. And that way we'll only have one unknown, which will be y in that particular case. Let's do this thing. So what do I have now? Instead of x, what do I write? So I'm pushing in for equation 3. Equation 2. I'm substituting equation 3 into 2. So this is taken from equation 2. So this is x, but where there's x, what do I write? I write 3y plus 1. This is my x. But how is this x? It is squared. So this x must be squared. Minus 2 into another x. What is the value of x? It is 3y plus 1 in this particular case. And then there's another y. That's what we have. Whenever you see something like this, I advise you that you do it same time. You do it together. Take this 2 and push it in there. Or take this y, you push it in here. So if you like, we can take that y, bring it this side. Then we're going to have the original 2 and that y, because both of them will be multiplying to this y plus 3. So we'll rather put it together. Let's go over it once more. We've pushed x here. That's what we have, substituted it. We've got 2, this is 2, this is y. Then we push x, this is our x, because the value of x is 3y plus 1, 3y plus 1. Plus, what do we have this side? We've got 9y squared equals to 17. Or from there, because we know that we are dealing with quadratics, question 1 deals with quadratics, we've got to put everything in the form of ax squared plus bx plus c equals to 0. So this 17, we bring it this side, so that will be minus 17 equals to 0. So we already have 0. This is the form that you want. Ax squared plus bx plus c equal to 0. So we already have equal to 0 that side. So I've got to have it in the form of ax squared plus bx plus c. In this case, it will be ay squared plus by plus c. Let's work it out. Go back to grade 8 and 9. You know how to square a binomial. 3y times 3y, it will give us 9y squared. Step number 2, 3y plus 1, it will give us 3y double that, it will give us 6y. Then y times y, it will give us 1. Let's do this once more. 3y times 3y, it's 9y squared. 3y times 1, it's 3y. Double that, 6y. 1 times 1, it will give us y. It's the same thing. If I give you something like this, x plus h all squared. What will I have here? X times x, it is x squared. X times h, xh, double that, it's 2xh, and h times h, it is h squared. So we're doing exactly the same thing here. Instead of x, we've got 3y. Instead of h, we had 1. So that's what we have. Let's break this bracket once more. So what do we have here? This times that, it's minus 6y squared. There's 2. 2 times 3, it's 6. Y times y is y squared. Minus times that, it will be minus 2y times 1, it will be 2y. We'll go further. It's plus 9y squared. You subtract that 17 as you see it equals to 0. All right, let's look at the like terms. This is squared, this is squared, this is squared. Let's make indications. This is y squared, y squared, y squared. These two, 9y squared, will give us 18y squared. 18 minus 6, if we've got 18 and minus 6, we're left with 12. 12y squared. This is 12y squared. So we are done with y squared. Let's look at y's now. Let's take them from the top. Y. Any other y here? This is another one. Any other one? There is no any other one. How many y's do we have here? 6. How many y's do we have here? 2. We've got 6y minus 2y's. We are left with positive 4y. So it's plus 4y this side. Let's look at those that are not tick either on the top or on the bottom. This is tick, this is not. Ticked, 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 not. So to make these marks helps me. So I've got positive 1 and minus 16. Minus 17, so this will give me minus 16 equals to 0. That's what we have. That's what we have now. All that we need to do now is to factorize. Factorize. So your factorization becomes very important in your algebra. What is the first step when you factorize? We open our eyes and we look for a common factor. You brush it up to look for a common factor. Which value will come in here, here, and also there? It is 4 in this case. Does 4 goes into 12? Yes. How many times? 4, 8, 12 goes 3 times. So this will be 3y squared plus 4 into 4 goes once, minus 4 into 16 goes 4 times. This will be equals to 0. That's what we've done here. We've multiplied each term by 4. We've divided each term by 4 so that we can find these values. Even that one was divided by 4 and it gave us 0. So this divided by 4 gave us 3. This divided by 4 gave us 1. This divided by 4 gave us 4. This divided by 4 gave us 0. So that's why we have those. From here, we factorize. Open 2 sets of brackets equal to 0. Let's see what happens here. We've got this y. Okay, we've got 3y and y. Right? We've got factors there that we must factorize this exactly as it is. So what is this going to give us? Let's say we've got 4 here. 4 and yes, 4 must come here. 4 times 1. 4 times 1. This is 4. So this is 3 times y, 3y squared. 3 times 1, this will give us 3y, right? Then 4 times y, it will give us 4y. How can we get positive? This positive, it means that the bigger one must be positive. This one must be negative to get us positive y. Right. So this is the positive y. We can get them there. So wherever you had 3y times 1, that one must be negative. Whenever you had 3y times 1, it must be negative. So it calls for this 1 to be negative. These 2 must be positive. Y times 4 must be positive. Y times 4 must be positive. So that's what we have. Then you write our solution. If we multiply 2 numbers, they give us 0, then the solution would be our y will be equals to, take this 4, that side it will be negative, divided by 3. So it's negative 4 over 3, or y is equals to 1. So these are the 2 values of y if we solve them simultaneously. So how are we going to find our x? Let me just continue from here. So we do have the 2 values of y, this one and that one. So we're looking for the values of x now. Remember, when we want x, we look at the 3 equations. Which one is better suited for us to get, feasible for us to get, to give us x? This one is x is equal to something. This is x squared. x and y. So this one will be much more easier to use. Let's jump and come to this section here. We know that we've got x is equals to 3y plus 1, or x is equals to 3y plus 1. Why am I writing them in twos? Because we've got two values of y. So wherever there is y, we are going to push in this one, and in the other y, you are going to push in that value. Let's do that together. Let's move. So our x thus becomes 3 into. What is the first value of y that we got this side? It is minus 4 over 3. So we take this y, you substitute it in the value of y there. So it is minus 4 over 3, minus 4 over 3. You close this bracket, then you add 1. Or, on the other side, we had x is equals to 3. What is the other value of y here? The other value of y is 1. So where there's the second y there, we've got to push in 1, then plus 1. What do we have this side? So our x will then be equals to, let us work this one out first. This 3 can go with this 3. We're left with minus 4. Minus 4 plus 1, it is minus 3. Or, our x then becomes, what is 3 times 1 is 3, 3 plus 1, it is 4. Then we write our solution set in terms of x and y. It will be, if x is minus 3, what was the value of y? If x is minus 3, what was the y that we pushed in there? It was this one, which is minus 4 over 3. And if x was 4, what is the value of y? It was 1. So that's how you write your solution set in terms of x and y. Thank you.